Hello and a warm welcome. My name is David Beavan from the Alan Turing Institute, and you're going to listen to a talk that I first gave and was invited to give at the University of Georgia in March 2023. In fact, it was the very first talk of the very first Humanities Festival they've held. So thank you very much to all at UGA for having me. The title is Weaving Humanities, Research, Software Engineering, and AI. And we'll return to this theme of weaving a number of times. How different appreciations come together to make up job identity, how different professions and roles come together to form a team, and how different disciplines come together to drive new research. You all look like you're ready to come on this journey with me. Here are the calling points. I'll start by introducing the Alan Turing Institute, my group and my role in it. Then, by looking at the large-scale research project, Living with Machines, we'll go through some research highlights, the challenges and learnings for others, including where arts and humanities can lead the way for other disciplines. And then we'll finish up with a bit of insight into the future of digital research infrastructure from the UK's perspective. Let me tell you a little about the Alan Turing Institute. I'm not allowed to shorten it to ATI. Another organisation got there first, so I'll likely refer to it as the Turing or the Institute. Established in 2015, we are the National Institute for Data Science and AI. We're based in the British Library in London and named in honour of Alan Turing, mathematician, philosopher and World War II codebreaker. And those code-breaking activities took place at Bletchley Park, which is about 1 hour by train north of London, and it's a museum now, and it's well worth a visit. The Turing has more than 400 researchers, from doctoral students to professors, along with many other roles such as mine, and it aims to cover all areas of societal impact. The Turing 3 goals are to advance world-class research, innovate and develop world-class research in data science and AI that supports next-generation theoretical developments and is applied to real-world problems. To train the leaders of the future, to train new generations of data science and AI leaders with the necessary breadth and depth of technical and ethical skills. And to lead the public conversation. Through public engagement, expert technical advice, we can shape the discussion on AI. We work across academia, business, and charities and non-profits. From security services such as GCHQ, which is signals intelligence, perhaps similar to your NSA, to National Air Traffic Control, health charities to banking. Turing is a unique mix of scholarship and innovation from inside of academia. It started with 13 founding universities, the most research-intensive institutions in the UK, the top of the top, although a careful glance will note that Northern Ireland and Wales are not represented, and Scotland only once. Turing has grown in diversity since then, bringing on 25 additional universities in the last 2 years. From April this year, its mission is truly national in reach. The Turing is for all. Let me tell you a bit about my group, the Turing Research Engineering Group, known as REG, or affectionately as HUT 23. In the days of wartime code-breaking at Bletchley Park, remember Alan Turing, the hastily built accommodation was in the form of wooden huts. HUT 23 was Bletchley Park's engineering group's headquarters, and we borrowed the name. We are a team of 45 and always growing. Over the last year or two, we've grown at the rate of more than one individual a month, which is just about as much as we can manage given the talent pool which is out there. I am lead research software engineer, which is equivalent to reader in UK academic rankings. I think that probably just scrapes a full professor in the US. We work across all disciplines and are the de facto interdisciplinary hub of the Turing, leading research, applying cutting-edge data science, AI, and software engineering to real-world challenges. We're made up of 3 roles: research software engineer, or RSE, that's me, research data scientist, and research computing engineer. In reality, everybody's on one big continuum, and we work as one big team. Research software engineers are not computer scientists. While there is some overlap between the skill sets of RSEs and computer scientists, the research software engineers are more focused on applying software engineering expertise to research problems, while computer science is more focused on the theoretical foundations of computing. And here's a bit of weaving for you. As James Hetherington, formerly of the Turing, said, research software engineers have 2 threads. The first of these, the scholar, is the archetypical researcher who is driven by a desire to understand things to their fullest capability, intellectually demanding problems attract rather than deter scholars. The scholar's curiosity is insatiable. The craftsperson, on the other hand, desires to create and leave behind an artifact which reifies their efforts in a field. They feel pain when the things they make are fragile or ugly. They prefer to make things which explain themselves. A research software engineer doesn't need to have that job title. It's within you. Maybe you feel a bit research software engineer. Maybe all the time, maybe just some days. But identity is important. Even the research software engineer role was only coined 10 years ago, and clearly many, including myself, were doing it long before the title came about. Today, I am proud to represent the 650 plus worldwide members as Vice President for the Society of Research Software Engineering. And catch me afterwards if any of this sounds appealing to you. Living with machines. I will call it LWM. This is the biggie. Nothing quite like it has been funded in the UK before or after. I'll give you a quick overview, look at some examples of the research we're doing, how it comes together, and some learnings to share. I want to stress the collaborative nature of this project. We've had 40 people thoroughly engaged in this over 5 years. It really has been a product of everybody's hard work. And whilst I might pick out some people, that might be because they've led it or led some aspects of it more recently, please do consult the whole team list. It couldn't have been possible without every single person bringing their best. We are looking at the British Industrial Revolution. We chose the time period 1780 to 1920, which more accurately represents decent source coverage at the latest point to fewer copyright issues at the more recent. Is really quite a pragmatic approach. This is a time of great change in society. The mechanization of work processes, the rise of the factory, the arrival of railways, population growth and shifts. And we aim to generate new historical perspectives on the effects of mechanization of labour on the lives of ordinary people during the long 19th century. We want to support the wider academic and cultural heritage sector in using digital methods to answer historical questions, to create new tools and code that can be reused and built upon in future projects, and to develop new computational techniques for working with historical research questions. Another big aim is to enrich the British Library's data holdings for the benefit of all, and to advance public awareness of how digital research in the humanities can enhance understanding of history. And this is one of my favourite images. On the right here, you can see the storage void of the British Library. This is where all the wonderful historic newspapers are stored, and it's all mechanised. A little robot goes up and down and will fetch the material to be delivered to the reader in the reading room. Anyway, living with machines. I argue this is going beyond your usual digital humanities project in terms of scale of funding, disciplines involved, and the number of staff and size and complexity of our data. Some might say computational humanities, but that term has a mixed reception. It's certainly weaving together of advanced data science, digital humanities approaches, and AI methods. We may be funded by Arts and Humanities Research Council, but we're their only project in that strategic priority fund programme for that tranche, and as such our progress is reported closely to government. We have £9 million plus over 5 years, and we're in our last 6 months or so, and our partners are the British Library, Queen Mary University of London, the Universities of East Anglia, Exeter, Cambridge, King's College London, and the Turing Institute, which is where the project is run from. We've also worked with many other organisations from Find My Past, the National Library of Scotland, the UK Data Service, and the Cambridge Group for the History of Population, and many, many more. We have 40 staff, past and present. Ruth Arnott is our principal investigator, and I want to give credit to all the contributors here when I highlight their work later on. I'm proud to be a co-investigator, and I had the very special honour and privilege to lead the project for 7 months this time last year. I spend roughly half of my time on this project, the rest is a mix from other humanities projects, to AI and power grids using electric cars as batteries on wheels, to all sorts of other wonderful things. You can see the weaving together of roles, such as historians, linguists, geographers, demographers, librarians, curators, research data professionals, and last but not least, research data scientists and research software engineers. We're currently in our final 6 months, and our researchers are leaving us for permanent positions. That's success for us. We've been a springboard for their careers. Mind you, half of them don't really fully leave, either being seconded back or have fractional contracts to stay it out. That says a lot to me, that we care about these people, and these people care about this project. To give you a perspective on what we've got to deal with, 109 billion words of historic newspapers. If an average novel is 100,000 words, then that's 1 million novels. If you live to 100 years old, that's 30 novels a day for your entire life. And you've still got to remember what you read, word for word, on day one. 129,000 glorious map sheets from the Ordnance Survey, the UK's mapping agency. They show amazing detail, and you get a peek at them later. 180 million household census entries, detailing who lived at an address every 10 years from 1841 onwards. Plus other sources to help build context, from newspaper and trade directories to novels from the Victorian era to railway stations and timetables. Let me show you some of our research highlights on language and place, then a tease of how it all comes together. The environmental scan, and key people here to talk to are Caspar Beavan and John Lawrence. It's tempting to get stuck into text analysis on the newspapers, start asking questions such as sentiment towards factories, how were industrial accidents reported, and my goodness, did the Victorians like a melancholy accident? But we should ask, what voices are in the newspapers, and how under and overrepresented they may be. Let's also remember that newspapers are just one genre of language exchange. People spoke to each other, read other forms of text, and had many other sorts of interactions. Let's work backwards. The digitised collection we have access to is approximately 6% of the entire UK newspaper collection from the time. So we have to ask, is that 6% representative of the whole? Then there's what's been preserved. Some publications have been lost in their entirety. Some are in so bad physical shape that they cannot be handled and digitised. Some were photographed decades ago onto microfilm and subsequently digitised from that microfilm, which is far cheaper but lower quality than revisiting the paper. I should say that the newspaper images were computer processed at the time, sometimes 10 years ago, not by us, using optical character recognition to read the layout and the text from the page. That process is far from perfect, as we'll see. What we don't know from the metadata is information about the political stance of the publication, its geographical reach, and its price point. To solve the last issue, enter Mitchell's newspaper press directory. Published annually from 1846, which is reasonable overlap with our time frame. It's designed as an aid for those placing advertisements in newspapers, and it covers the information we're looking for. Given the motivation, we have to take what's reported with a critical eye. It's obviously in the newspaper's interest to over-report things like circulation numbers. We are looking to make this available openly as images and as structured data, as well as an enhancement to other data sets. Here's an example from the Chatham News. We can see it's twice a week on Friday and Saturday, costing 1 old pence. Somewhere in the middle right-hand side it says this. Below that, on the left, we learn it is independent in its political stance. And we have information about the places it circulates, topics, and even ownership. Perfect to link with what we have. But not so easy. We had to go from the page image to structured data, and that involved a number of things. Image segmentation, to understand the columns of the page and how information flows, as the entry goes from the bottom of one column to the top of the next. Text segmentation, understanding where the record for each title starts and stops, understanding those changes in fonts and what they mean, and that turned out to be a hard one for us. Semantic annotation, understanding where each piece of information, price, politics, etc. is in that entry and what it's signalling to us and how that fits with our labeling scheme. And we have to link this to our external records, the newspaper database, trying to match the newspaper title to the title we have in the main list, and sometimes we have OCR mistakes. Sometimes we have situations where the newspaper title is represented differently. Using the context of the geography, we can help disambiguate one Daily Tribune from another, for instance. And this was all accomplished using AI deep learning tools and transfer learning. Transfer learning is how we can take an existing AI model that does one thing well and transfer its abilities to another challenge, and with additional training, get it to work there too. We might have a model that's good at identifying cats in images, so with transfer learning, we can make it work to spot dogs in images instead. Here we used UNet, which is a biomedical image segmentation model, and applied it to the task of segmenting the page into entries for each newspaper. BERT is an AI language model which we used to identify the semantic embeddings, which took additional training on our labels describing politics, price, etc. Always with the human in the loop to help train and improve that model. Here we can see the structured data extracted, showing how the Portsmouth Times changed title over the years, how its political stance changed and ownership too. Time progresses from 1855 at the top to 1869 at the bottom. I'll give you a moment to take that in. And you can see that one Portsmouth Times managed to sneak in here as well, and we don't have an ownership for 1867. Well, what does this tell us? Here's a view of political label, liberal in orange and conservative papers in blue over time. Time being the x-axis going from 1840 to 1900. The y-axis is the proportion of those labelled newspapers compared to the whole in that year. Square markers are what we see from Mitchell's press directories, and the crosses are the proportions from the newspaper digital collection we have. We can see a disparity here. From Mitchell's, the squares, we see that for the majority of the time, the liberal press has more titles than the conservative. So the orange line with squares is above the blue line with squares. But look at the content we have to work with, the crosses, and we see that for more than half of the time, it's the conservative press that outnumbers the liberal. The blue line with crosses is above the orange line with crosses half of the time. And we can see this divergence if we look at price point and other measures too. So coming back to base bias, we can say that the digital collection is not representative of the whole, and that has helped us commission new digitization to help plug the gaps. Can we say the newspapers aimed at working class people? Content which was not conservative, was sold at cheaper price points, on poor quality paper? That didn't survive well, it didn't get digitized, and therefore didn't make it to our corpus. I would like to give a quick mention to some of our crowdsourcing tasks now, and key people to talk to about this are the likes of Mia Ridge and Kalle Westering. The newspapers present as a diachronic corpus from 1780 to 1920. Many new words appeared in that time, and many words changed their meaning, sometimes subtly, sometimes more obviously. I already spoke of melancholy accidents, as that was the top word pairing for accidents in titles of articles. While I understand the sentiment, I don't think that's how it might be phrased today. One difficulty is that natural language processing software trained on English tend not to understand historical language so well because of the shift in meaning. So we're looking at teaching them to do so. To do that, we need training data, and that's where our wonderful 2,800 volunteers on Zooniverse come in. We want to know, what was a machine? Was it animate? i.e., did people think it had its own will? What kind of machine was the article referring to? Usually a sewing machine. There were many adverts for sewing machines. There are a number of tasks on Zooniverse you can get stuck into after this talk, such as the meaning of the word car. That's something which has diverged between US and UK English as well. It's hard lines on Skirton that other parts of the town should have electric cars, and that this, one of the most populous and thriving, should be cut off without them. Yet Skirton is not in hopeless case after all. It has the horse car system, and it is not the corporation's fault that it cannot be linked up with the electric system this side of the river. I think we've got two uses here for Skirton, which is a northern district of Lancaster, across the river from the castle. For this task, there are two instances. I think one is, quoting the specification, a wheeled, usually horse-drawn conveyance, and the other use is an electric tram car or streetcar. Let's take a look at two challenges of place names and changing geographies. Toponym disambiguation. And here, a big shout out goes to Mariona Cole-Ardnui and Federico Nani for their work. It's the process of identifying a place, even if others share the same name. If we're to understand the events and language of place, we need to know what that place is. And I've lost count of how many new ports the UK has. Those new ports just sprang up everywhere. A gazetteer is a place name dictionary. It lists all the unique places of interest. Our task is to link the lexical form in the text to the correct place in the gazetteer. From there, we can springboard to maps, census records, and newspaper text. It's not that easy. Our text being digitized and then having optical character recognition run on it, sometimes decades ago, is messy. Very messy. If the word accuracy is 95%, i.e. 95% of all words are correct, that sounds good. But all it takes is a 14-word sentence, and statistically, the chance of that whole sentence being right is now less than 50%. So this process has to be robust and able to work around OCR mistakes. Even if we can read the place name correctly, does that map onto gazetteer properly? Maybe. But some place names have variant spellings. Can it be flexible there? My grandparents used to live in a place called Thornton-le-Dale, if you believe the posh road signs, and simply Thorntondale, if you believe the others. And what if the gazetteer has multiple entries for that lexical representation? The Newport problem. Can the context of the newspaper article help? Here we can see the challenge. Of all these references to Ashton-under-Lyne in the corpus, they all relate to the same place, and there is only one. but this gives you a sense for how it's being represented in our corpus. Our solution is to use deep learning and fuzzy string matching to identify candidates in the gazetteer. There's a wonderful open source Python library called DZMatch, which we've released to do this. Others are very welcome to download and use it, and we'd love to know how well it works for other challenges. It appears to be very resilient to the errors we see in OCR, and it was also used to help match those Mitchell newspaper titles to the main list of newspaper titles, which is a very similar challenge. The final stage is contextual. The gazetteer is enriched with topics from Wikipedia on that place. Is it known for coal extraction? Is it a manufacturing base? Is it still rural? If we do the same to the article the place name appears in, extract salient topics, that can be used to narrow down the link. And that's how we do it, at scale and using computational methods. It does record a confidence measure, so it is possible to keep only the most confident matches. Map reader. How can we understand land use at scale from maps? And all credit to Katie McDonough and Kazra Hassini for leading this work. We are very lucky to have so many detailed maps in the UK. I could look at them all day long. This is of the area where the Turing is based in 1914. See the goods shed on the right-hand side. There's so much information here, if only we can read it at scale. Some research takes a vector approach, trying to trace roads, building outlines, etc. We are interested in land use, so take a different approach. This is a superb animation of how Scotland was surveyed, and when the year the sheets were first published. So note here it took 30 or so years to reach full coverage to the islands of Orkney and Shetland, there in the northeast. The Ordnance Survey did revisit the entire nation a number of times, so we have a diachronic corpus here too. And our gratitude to the National Library of Scotland for their permissive licensing and their amazing collaboration. MapReader is an end-to-end computer vision pipeline for exploring and analysing these images at scale. It was inspired by the patchwork method used in biomedical imaging and geographic information science, and as a tool has gone full circle back to science, being used to classify plant phenotypes. It can take map tiles from online IIIF sources such as libraries or local resources, and then divide that map, that image up into different grids, different patches. Each one is classified. So for our purposes, we wanted to label commercial, residential, and rail space to begin with. It requires human annotation to train the model at the very beginning, but quickly can move into inference, where it's classifying the map content, and again, with human in the loop, can always tweak that model to really increase the performance. With this, it gives us unprecedented access to how the country changed due to industrialization and how patterns of that process emerge across different towns, different places. At this point, I should say we have a book with the University of London Press coming imminently, so I can't really spill the beans too much, but I want to give you a peek of what happens if we draw together the different sources. It's the linking and seamless moving from one source to the next that gives us new insights. Come with me into this dream world. Imagine if we were to bring this together, moving from maps and an understanding of land use, to location, to distance, to how well connected places were, to demographics of the people who lived there, to the sentiment of those people and the locations towards mechanization. Nice. Then do that over the whole time period we're talking about, not just as a case studies of particular places, but everywhere. What happens when the railway arrives? Do neighbourhoods get physically divided? Are people newly connected by means of transport to elsewhere? Do those who live near railway lines suffer noise, smell and dirt? Do those who live near stations, but not too close, gain benefits from being connected? How does this affect different classes of people? New jobs, a new manufacturing occurs. What people made bicycles before bicycles were a thing? Where did those skills come from? All good questions, and whilst I can't tell you right now, publicly, do speak to me afterwards. I've tried to pull out some of the perhaps expected and unexpected challenges and their learnings encountered in living with machines. Explore bias and representativeness. This is a core component to ethical research, be it humanities, data science, or AI. This is an area where arts and humanities thinking and methods can really teach other disciplines how to work with incomplete pictures of reality. I've seen too many times other disciplines not pause to ask questions over the sources and data they are using. I've seen car usage data taken from electric vehicles and used to predict movements of other vehicles, without pausing to ask if electric vehicle ownership is representative of all car ownership. Worse still, nobody stopped to ask if anything unusual was happening in the time frame the data was collected. It quickly transpired this was during the pandemic lockdown. Workplaces were closed. At many points, non-local travel was banned, and trips out the house were limited to one a day. That wasn't normal. Do we correct bias or work with it? In our case, did any one human have an average life exposed to average language, average society, average family, average job? Quite probably not. So perhaps trying to correct for bias is not appropriate, but understanding it, its extents, and dealing with it as part of the human analysis is something to absolutely spend time doing. And just as model cards can describe AI models, I think of data sets in my mind as maps. Some areas have clear, open space. Lots of people go there. It's well understood by scholarship, like the 1850s to 1900s section of the newspaper corpus. But go to the 1780s and there are far fewer newspaper titles. They are skewed in what they represent. In my mind's map, there are warning signs here. Tread carefully, it says. Take mountaineering equipment. Be data ready. The plan for living with machines never put much emphasis on maps. That was opportunistic. Why? Because what we saw as our central source, the newspapers, wasn't available to us in day one. It took 3 years. In our case, our project partner, the British Library, holds the physical copies of the newspaper. The digitization of them has, in the main, been performed over decades with numerous sponsors. There was never any central public funding for this. Ultimately, the ownership is with DC Thomson, the publisher. Access is all geared up for portal-based searching and not the large-scale analysis we need. There was no API access either. We needed a copy. So alongside the copyright, the database rights, data protection, we have to deal with commercial sensitivities and the time taken to ingest the data. This was deemed so commercially sensitive that the data must be stored and analysed in a trusted research environment, alongside the likes of medical data, police information, and jet engine blueprints. All of this hampers our research outputs. Others cannot, unless they go through the hoops above independently, reproduce our research. While we can share our findings in articles and our code on GitHub, the data isn't accessibly easy for others. What we have been able to do is work with some of the newspaper collections that are less encumbered, such as the material we commissioned for digitization, and that does amount to 500,000 pages freely available. We can always publish subsamples of the whole, but it's still deeply, deeply unsatisfying to know others cannot easily build on our work on the UK newspapers. And our collective history and heritage is being held to ransom by commercial deals. Share what success looks like. This is something we did early on, and it really helped build bridges as well as inform how different combinations of people could form effective teams. Whether that be what the funder values, here it's a blend of traditional research outputs, digital outputs, and reflection on the process. Living with machines is a big experiment. We're coming here first. Others need to learn from that. For the organisations we represent, the British Library is focused on holdings and what it means to do digital scholarship. The Turing sees everything through a lens of data science and AI, and how work in one area can feed into another. Different professions value different outputs. For a research software engineer, it's important good quality code is made openly available, that we value teamwork, and we drive research outcomes, and those research outcomes are seen as the embodiment of those previous values. And it's very different for junior academics in history who need to build their publications profile, for instance. Our career paths vary too. We must acknowledge what each other need to move on to the next stage in their careers, or if people wish to move track. We've had 2 researchers convert to other sorts of roles and other positions, for instance. And values and norms vary widely too. In the sciences, multi-author papers can be the norm. In arts and humanities, that's not the case. Same goes for how open different parts of the project wish to be. Some being very scared of being scooped, others working in the open and transparently by default. It's been important for us not to experiment with people's careers. While we, as a project, can lead from the front, our staff need to make a success of their careers outside of living with machines. You might be asking, what have we been weaving? What is coming out of that loom? I argue, in many respects, it's the foundations of a digital research infrastructure. The UK has been here before, with a limited success, in the shape of the Arts and Humanities Data Service in the 2000s, and the US perhaps notably in the shape of Project Bamboo in the 2010s, again with limited success. The UK does have observer status to 2 EU initiatives, Daria and Clarin. We're taking an integrated view of the digital research infrastructure, and one unashamedly built on technology, AI, and the digital economy. It's compute, high-performance computing at a number of tiers, from local to national levels, with packages and software for all workloads, from chemistry to computational linguistics. This includes the need for AI accelerators, such as GPUs, but also point-and-click cloud-based solutions for institutions that have the finance, but not the staff. It's storage, sources, data, and the mechanisms to handle their description, finding, licensing, access, and provenance. Datasets can be subsampled, can be enriched with additional data, can come in a variety of versions. The aim is to make this as seamless as possible for the researcher. But there's no point in having those resources if there's nobody to drive them. So skills is the third thread. There's a wide audience here, from undergrad through research active staff to those who plan and review proposals. Digital methods is never going to replace all arts and humanities scholarship, nor should it, but my goodness, does it open doors. Finally, we need to keep data safe, whether that's commercial sensitivity, as in living with machines, keeping personal information like medical records safe, or national security. Trusted research environments or data safe havens are needed, but we need to make them easy to use. Until 2018, the UK research funding scene was made up of different research councils competing against each other for resources from government. Now, we have UK Research and Innovation, which brings together the 7 research councils. What this means is arts and humanities is at the table and being listened to. It can play a part in UK-wide initiatives and make its own demands. It can make demands of cross-council investment, for example, exascale compute, where we've proven typical text analysis workflows need a specific architectural design of high-performance computing. There are a number of real and present challenges. The timeline of activities usually means investment is tied to projects. Sustainable communities, the adoption of methods and software play out on much longer timeframes. Continuity is being lost. Outputs are being deposited, but go stale quickly. Software generated can be too limited in scope for others to easily adopt and use. It might be too specific to one project, inadequately documented or supported. The wheel keeps getting reinvented, either because we lost the last one or nobody knew where to look. The pool of technically skilled scholars and research practitioners is limited. Recruiting and keeping talent is very difficult when we compete with other disciplines and the commercial sector. To drive new research with new methods, we need abundant skills, and quickly. The Arts and Humanities Research Council is the research council which faces all collections in the UK, regardless of their subject matter. So that's from art galleries to medical collections to dinosaurs in the Natural History Museum. We want to see the value in those digital collections realised. And thank you. I've always wondered how I can justify a dinosaur in a presentation, and now I have. Finally, all this is for one purpose: to grow research, not to answer existing questions, but to ask new questions, linking collections at one end and new research at the other. We need to be weaving humanities, research software engineering, and AI. And thank you. Thank you for listening and watching along. At the bottom, you'll find my Twitter and Mastodon contact details, or you can find me through other social media platforms. Feel free to ask me questions. I'm very happy to respond. And once again, thank you so much to the University of Georgia for inviting me across to give this talk. It's been an absolute pleasure. Thank you to all the amazing artists that have helped spice up this presentation. And I'll leave you on this slide.